Hey there YouTube, this is SJM4306 back with another review. This time it's something that is going to be very useful if you are into electronics hobbyists. I could imagine, I don't know, like kind of simple biology stuff maybe. If you just want to look at things that are tiny, maybe jewelry, I don't know. But basically if you need to inspect things that are tiny, you really should get yourself some sort of digital microscope. They have really come down in price. This is from a company that very kindly sent it in to me. The name of the company is KMDES. I have no idea how to pronounce that. Not even going to insult them by trying to pronounce it. Anywho, this model in particular is 60 bucks, and there's a $6 off coupon. This has the plastic base. They have a version with like a nicer metal base, and the stand is all metal. And it's only 10 bucks more, so honestly, in my opinion, I would just go for the metal base. Especially if you are going to use this for, like, soldering. I have an Andenstar, which is actually just right in front of me. I just tilt the camera a little bit. There you go, that's my Andenstar. I use that almost every single day, and it is one of the most useful pieces of equipment that I have, especially with how small the things I solder. I really do need, like, my eyes are getting slightly worse, not horrible, but definitely need some kind of powered magnification nowadays to be able to see what I'm doing. Anywho, yeah, so let's just see what exactly we get. Yeah, KMDES 4.3-inch IPS LCD. It says 32 gigabyte card. There is a sticker, but it's not really. It's barely on there. It does do your whole host. Wow, there's something rattling around inside. Everything's rattling inside. Hopefully this arrived undamaged. But anywho, 4.3-inch display. It does photos, videos, and it looks like it does. It says multiple output mode, and then it shows HDMI. If it has HDMI, oh my god, that will be super useful. My favorite thing doing with my Andenstar, it has HDMI out. I hook it up to an old, like a $5 computer monitor that I got at the thrift store, and it makes it like a 20-inch screen microscope, and it's so good for that. I've featured that in past videos, so yeah. You can see here, they show you how to assemble it infographically, and yeah. So yeah, the difference is the H, I guess, is the metal one, and without the H is the plastic base. So yeah, we'll get into this right now. Okay, there is a plastic insert that, there we go, to kind of keep everything in place, and there is some foam over the LCD, so that's good. This is apparently, what? A micrometer calibration ruler. Oh, wow! Oh, we're gonna have to take a look at this. It looks like a gray square, but I bet you, yeah, there's like a very fine grid printed on there. So you can actually use this, inspect this underneath the magnification, and I guess, I don't know what you'd really be calibrating, but yeah, you could just use this, I guess, as a reference for measurements. That's pretty cool. I haven't seen that before. None of my other microscopes have come with that. We have the user manual, version 1.0. Fancy. And yeah, it's got a LED ring light too, and in terms of like the user interface, looks like a dash cam user interface sort of thing going on. And yeah. Some of these have remotes, which is really nice because you don't have to touch the microscope to click buttons, which would often jostle what you're looking at. This model does not, unfortunately, so this you will have to manually control. So, we have the microscope itself here, and it does have a glossy screen covering. There is a protective film on it. We'll take that off in a sec. It is all plastic construction. It does have sort of a, it's got some dust in it already, a plastic covering to protect, because the lens does actually stick quite a bit out, and the LED ring light we can see right in there. So there is 8 LEDs, yeah. The focus mechanism is actually pretty tight. It's not like super tight, but oh yeah, wow, wow, that's a far travel. So it was like at the end of travel, I'm guessing, almost, yeah. And then it goes all the way inside. So that's quite interesting. So the important thing for these microscopes in relation to soldering is the working distance. How far away can you get the tip of the microscope to the surface, the work surface, and still be able to focus on whatever you're doing. You don't want it too close because then you can't get a soldering iron underneath there. I would probably only use this for inspection because the plastic base is gonna melt and burn if you try to actually solder on the base. So I would probably try to avoid using the plastic one, but like I said, just get the metal one. It's $10 more. We have some clicky buttons on the bottom, which is good. I believe this has a battery built in. We have a analog like volume wheel for the brightness. That's cool. 5-volt DC in, USB-C. Thank you. A micro SD card. Oh, it does come populated. It does. I guess that's why it said 32 gigabytes. So thank you very much. Yep, it is a memory card, HC branded memory card. Okay, it's 32 gigs, so yeah, there's a reset hole next to that. This is one of those that if you're not careful, it'll ping off, and yeah, the spring on this SD card is like pretty strong, so you just gotta be careful with that. Just leave it in there. We do have a power button on the back there. We'll turn this on in a sec. We have the stand, which has like a set screw, and then an adjustment knob that moves. Huh, that's interesting. Oh, so the coarse adjustment is basically the set screw, and then this it would be considered the fine adjustment. And there's another set screw here to actually attach the microscope. That's an interesting way about doing it, and it's labeled up down. We have the plastic insert. Set that aside behind me. We have a USB-C cable, which I'm always happy to see free cables. I mean, not really free, you're paying for it, but at least this one looks to be, let's see what the length is. It's about 2 feet long, so, I mean, it's like decently thick. It doesn't feel like super cheap. Yeah, I mean, if this is battery powered, I'm probably predominantly going to be using it battery powered. It's nice that it does come with a cord though, so definitely happy to see that. And looks like we have a metal screw. This is the set screw for the base, and okay, this is the post that everything rides on, and it looks like there is a molding so that you could fit the cord through that, maybe? I guess? I don't know. But, anywho, yeah, this should just kind of fit in here. Might take some finagling. Yeah, there we go. Yeah, I mean, it's not super smooth, but, I mean, it'll get the job done, especially for, like, sub $100. Expectations aren't super high in terms of like the precision. I mean, this really isn't a precision kind of microscope or anything like that. So we got the base in. We do have clips for slides, which you probably are going to, if you want to remove these, I mean, I'll probably just swivel them off to the side like this, because I never use those. They just get in the way when you're trying to put a circuit board in. You don't necessarily need to clamp it down. But yeah, if you want to remove those, probably I would guess that there's a screw on the inside. So you have to probably take off the feet, and there are probably screws in each corner. You can remove the bottom of the base, and there's probably a screw that goes into that. But yeah, it's not that big of a deal. I'm just going to kind of push them to the back there and leave them there. There is a reticule for measurement that is laser engraved. Interesting. Plastic quality is not like super high quality, but I guess it'll get the job done. Interesting. Okay, so these can actually unscrew it. Look. Oh wait! Oh, I just realized. Okay, so the left one, there, it says up, down, and then the other side says unlock, lock. That's why I was thinking this one should also move it up and down, but you set the height, and then you can lock each oh, that's very neat. Each axis you can independently lock. That's pretty cool. And then we're just going to carefully set this in, and get the set screw in there. Just snug it up. just so that the screen doesn't go anywhere. And I guess while we're at it, let's take off the protective film. So let's have some ASMR time. That was pretty good. Just gonna set that on the manual here for no particular reason other than, yeah, come on, there we go. Just to keep it out of the way, and I guess I could always put that back on if I really wanted that for some odd reason. Okay, so I'm gonna move the box now, and I'm gonna have to get the camera set up. Probably this reticule thing would work much better on a white background, like the manual, for instance, if I just flip it over, because the base is black, so it's going to be kind of hard to see contrast. And one thing, the screen does articulate. Yes, that is good. Yeah. Okay, so I'm going to have to get this set up a little bit better, because the way I'm filming top down, so you're not probably going to be able to see the screen very good. So the rest of this may be handheld, but yeah, give me a sec. Okay, here we are. I'm going to press the power button, see if it has a charge. Welcome. Boots up pretty fast, like less than like maybe 2 or 3 seconds, if that. We have the light here. I turned off the overhead light because you're not going to be able to see anything pretty much. And it looks like it turns completely off. And then when it's completely on, yeah, it gives off an okay amount of light. I guess I might as well turn this, my second overhead light, off. The resolution on the screen, it reminds me early day camcorder sort of thing. So this is probably like the same resolution as a PSP. It looks about the same size, maybe a little bit smaller. No, probably about the same size. It says, though, the recording quality is set to 720p. There is an offset, by the way, I've just noticed, between the front bezel, the plastic lens, and the LCD is slightly behind it. So if you're not looking head-on, it kind of can cut off some of the text. You can see the 7. You can't see the top anymore. And when I go down, you can. But, small detail. It has, I guess this is like the remaining recording time at that 720p resolution. It does have a microphone, it looks like. It has time in 24-hour time. We'll see if we can change that to 12-hour time. I prefer. It doesn't really matter, but It has a date, timestamp, all that. Battery indicator. It says it's like about full, it looks like. And the SD card indicator. And this is in video mode, obviously. So, I guess I will see if I can focus this. Okay, I am properly focused. I just had to twist this. I forgot I had it all the way up. And so, yeah, you can see here, it has the test calibration. It has the line thicknesses. So, I guess, yeah, it increases as it goes down. And we have the reticule on the bottom in millimeters and inches. We have this guy, which is sort of the coordinate shaped. Okay, division equals 0.1 millimeters. Interesting. We do have, yeah, there we go. Diameters of circles. You can see. I'm guessing this is like acetate. It looks like something like that. You can see the smaller feature size. There's some, like, obviously the printing process that they used looks kind of digital, because the smaller the circle gets, you can kind of see some kind of like quantizing stepping sort of thing going on. But yeah, like you see aliasing. It's not exact, you know, like a nice round circle. But yeah, and then let's go to that grid. It looked really dense. I could barely see. Yeah, there you go. So I can clearly see this grid. Grid shaped. Division 0.1 by 0.1. So yeah, I I mean, so far, it seems to work just fine. I want to get something more interesting than just this calibration card, because we're not really calibrating anything, we're just focusing it. But let's grab some electronic components and whatnot that might be interesting to look underneath magnification. Okay, this is like the third time I'm recording this. So I have the SD card inserted, it's formatted, I'm gonna hit record, and it should be recording. I cannot get this to record to the SD card. It'll show up like, I think it's like not actually closing the files or something weird, because it'll show up if I immediately stop recording and then go into like the playback mode, then I can play it back on the unit itself. But as soon as I take out the SD card, like I'll shut it off properly, I'll wait a couple seconds, take out the SD card, put it in my phone. I try to load it up into my phone, it shows up there's no files on it, nothing. And it doesn't even show that the memory is consumed or anything like that. So I don't know what the heck it's doing recording. So if you're going to record with this, I'm just going to say don't even bother relying on the internal SD card. It doesn't seem to work at all. I cannot get it to work. The card, I don't know, maybe the card's faulty, but I did try a second card that I know is good, a brand new card, and it did the same exact thing. So I'm just going to say this, yeah, just record if you want to record, just like point a phone at the screen or something. I don't know. Anyway, I've done this 3 times and it's pissing me off now. So, okay, we are actually looking at an electrophoretic display, which is an ink display that you'd find in something like a Kindle. This is a 3-colored one. However, I only have 2 of the colors on here. This is actually just ambient light. So if I just put my hand here, you can see it blocks out the ambient light. You can use the onboard LEDs, which there is like an auto white balance it does to adjust. But you do get a little bit of glare. You can see in the corner there. It depends on the angle. Interesting thing to note about this type of display, if I take you to the corner here, you can see, let's just turn that down. There you go. You can just about see a little more. There you go. The red pigmentation here. Over time, I haven't ridden to this display, this particular display, in about a year. Maybe even more, actually. And you could see sort of this pinkish, reddish hue that's starting to come to the surface. That's natural. You're supposed to periodically write to these displays to keep them like pure black, white, or red. Because after a while, it will sort of fade the red-ish color, and the sort of a pink background color will start to rise to the surface. And that's just physics. But if you look at the pixels here, if I focus in, you can see that there's this hexagonal grid, and those are basically little compartments that contain a viscous liquid as well as 3 different colored balls, red, black, and white. And the black and white, I believe, are the same size, but they're opposite charges. And the red, I believe, is the same charge as the black, but it's much larger. So physically, it takes longer to travel through the fluid than either the white or the black balls. And the way that it works is there are electrodes on the top and the bottom. You'll notice that the alignment of the actual pixel outline shape isn't aligned to the grid at all of the hexagonal little capsule sort of pods or whatever. And so basically the electrodes are what define, which are clear so you can't see them, is what defines sort of the pixel grid. And so to write black and white is easy. You just charge it so that the white falls to the back and the black comes to the top. To get red is a little more complex. You actually have to bring all the red and the black to the top, and then you hurry up and you switch the polarity. So then the black starts to go towards the center, and you stop the timing on that so that the red just starts to, go backwards, what is the predominant color in the front. And that's basically how you turn on and off each of these subpixels. The only thing is for like a 3-color EPD like this, it takes significantly longer than just a pure black-white one because it physically takes longer to bring those red pigments all the way to the front. So yeah, I just thought that would be pretty interesting to take a look at this. I just have like a character font programmed and written to the display. The display, if I peek down, is actually not plugged into anything. So yeah, it's unpowered. It's been unpowered for quite a while, but it retains the image because of that viscous fluid, and it's not, doesn't require any power to maintain the image, which is why this is perfect basically for like an e-reader. It only takes power to update the image. But yeah, thought you guys would be interested in that. I'm going to take a look at these files and hopefully they survive so that I can at least show you what the mic quality sounds like. But I also am recording it through my phone right here in case this fails, because I'm not going to do this a fourth time. Also, thing to note, so I can't get the SD card recording to work or anything, but while you're using it, there is a digital zoom, as well as obviously the optical zoom of you moving the lens and like adjusting the focus. You can use a digital zoom. It goes 1 times, 2 times, 3 times, 4 times, 5 times, and that's it. It goes up to 5 times. So there is grain on the image now. I can see sort of a crawling dot pattern. But yeah, I mean, this might come in handy because the optical zoom is limited to a certain point. Just to note also that the working distance, so to get this close to the display, I'm really only like a couple millimeters away. So I would not obviously use this for soldering. You're not going to be able to get the soldering iron under there without like melting the this plastic protective cap or anything like that. So this is really only, I would use this honestly just for inspection of solder joints to make sure things are soldered correctly and that there's no solder bridges or shorts or anything. So yeah. Okay, so here's an example of something practical you might do with this. I have a PCB, say I just soldered this, and it's not working for some reason. So what I would really need to do is inspect all of the solder joints. You can see there's a bunch of flux here. That's what that sort of liquidy stuff all between those pads. That's not conductive. I really should clean that off. But it's not, probably not. It's not gonna affect the board working or not. This board does work. I've already tested this. But anyway, just for notwithstanding. So for example, that might look kind of suspicious. So I might want to zoom in on that. So I can use this digital zoom to get closer and see, no, that's just some extra flux in there. Also, sometimes it helps changing the angle of viewing. So there, okay, yeah, then you can see, okay, so that is just flux. That's not a short, it's not like a blob of solder in there. And so yeah, that's what, these microscopes are actually pretty good. They don't have a very like wide field of view necessarily, or like a range of focus. But once you get it focused in there, you can quite easily see if there is going to be a potential problem with shorting. And you can inspect all the solder joints this way. So let's just take a look around the board. We have our switches. You can change the plane of focus, obviously, by adjusting the fine adjustment on the lens itself. And let's just see. We have a capacitor down here. Oops. There you go. You have to be pretty gentle with the adjustment because it's pretty easy to go too much or too little. You can see the silk screening there. That looks actually pretty nice. Cool beans. We have a resistor. You can change the focus from the top. Oh yeah, I forgot. I am all the way zoomed in too. So just take it back out to 1x zoom. You can see capacitors, resistors. This is the USB bridge chip, CH340C. And we have the USB connector. We can see all the pads there. That pad might, I mean, it is soldered, but maybe could use a little bit more solder. All the other ones have plenty of solder. But yeah, like you can inspect different things like this. We can see the LED here. If I just tame down the backlight, there is sort of like an auto white balance, it appears. There we go. So if I just zoom in a little bit on this, you can see the LED. It's a surface mount LED. There's the actual die itself, which is that small kind of darker colored square. The pad, there's actually 2 pads. There's one pad here and one here. One has like a little cup that holds the LED chip, and then there's a gold bond wire that goes over to the other pad, and that's what makes the LED be an LED. On the other side, we have another similar LED, just a different colored one. Obviously, it's not like the chip inside It's not like it's colored with like a filter or anything like that to generate a different color. It's the actual band gap of that semiconductor that determines what color will be emitted when the LED is turned on. Anywho, let's just turn this up, zoom out. So yeah, overall you could, this is what this is telling me is I need to clean my boards better, because look at all of that flux. Short term, it's not going to do anything. It's not going to really affect anything. But long term, if you, even with no clean fluxes, I'm pretty sure they're supposed to be like pH balanced. But long term, I still don't really trust it. So I would probably, just to be safe, just clean all the flux off, put this in an ultrasonic bath with some IPA or some other dissolvent. You can use PCB cleaner spray as well, and that's specifically formulated to safely be able to clean fluxes off. You can see the laser etching on this chip, the Atmel chip. That's actually quite interesting. And yeah, anywho, we have some pads down here and silk screening, etc., etc. Yeah, so I just wanted to show you guys a practical example of, say, something that you'd use, something that you'd inspect, which, just looking at it like this, I mean, the lighting's not good here, but just looking at it like this, all the solder joints look like perfectly clean and good, but obviously once you get it under magnification, you can see that there's quite a bit of flux left over that I probably really should clean off. Okay, so I guess in summary, we're at that point in the video, do I think this is a good deal for about the $60 that it's going for right now? As like a standalone digital microscope, yeah, I'd probably spend the extra $10 though, like I mentioned, and get the metal base and the metal stand, and that's just going to be so much nicer to use. So if you're just going to be using this to inspect solder joints or whatever, then yeah, I think that for around the $60 price point, yeah, this is absolutely worth it. It's worth having one of these in the lab, just to, you know, to help you inspect things that aren't working properly, et cetera, et cetera. If you do intend to use this for like the recording capability onto the SD card, I honestly couldn't say. My experience was that it didn't work. I could not get it to work. I tried many times. I swapped out the cards. I tried a brand new card direct from like a sealed package that I bought, and I know that card works absolutely fine. I was not able to get it to record. One time I did get it to, it created a file which then I guess was never closed. So then when I plugged it into my phone, it showed up in the lost directory, which means that the file was corrupted. And I was able to rename it and play, but it was like a very short clip, and like I couldn't actually make use of it. What I could hear about the mic quality, it was mediocre. I wouldn't use this to, I mean, I guess if you wanted to make like some kind of verbal note or something as you're looking at like a sample of something, fine. But honestly, yeah, I would just use this for inspection. I couldn't reliably, get the microSD recording to work. So obviously I would not rely on that. Your mileage may vary. It might be that I have a defective unit or something's wrong with, the actual SD card slot reader inside, or I don't know. Could be any number of things, but as I couldn't get it to read, I can't recommend this for someone who wants to record directly to the SD card. There's no other video inputs to it. Would have been nice to have HDMI input, but I could definitely see that would increase the price, in which case I'd have to reevaluate. If this were closer to like the $100 mark, I'd really have to think carefully, because there are other much larger screen digital microscopes within that $100 to $150 range that generally have better quality than this. So I'd have to reevaluate that if they start adding features but also raise the price. But with this feature set at this price, I think this is a pretty good investment for inspecting your PCBs and whatnot. And I obviously you can't really use this to solder like real time, unfortunately, because the working distance is so low. You can see my finger there. Hello. But yeah, but for inspection, this is still useful. I can't tell you how many times that I soldered a board, it didn't work, and then I looked at it under the microscope, and there was a very obvious solder blob that was like shorting two pads, and it wasn't obvious directly with the naked eye, even with good lighting. So my eyes aren't they're actually still pretty good, but definitely they're not as good as they used to be. So I have a feeling I'm going to be depending on digital microscopes like this more and more in the coming years. So anywho, if you guys are interested, I will have links to this guy in the description down below. And once again, huge thanks to the manufacturer for sending this in for review. But anywho, hopefully you guys enjoyed this video, and ooh there. I'll see you guys in the next one. Bye.